Hi everyone. In this video, I will introduce our work, SVHalluc, a benchmark for studying speech-vision hallucination in audiovisual large language models. Audiovisual large language models are becoming increasingly capable. Given video, audio, and text as input, these models can generate natural language responses about complex multimodal content. Recent systems, such as Qwen 3 Omni, show strong progress in video understanding. However, as these models receive more modalities, they also face a new risk: multimodal inputs can induce hallucinations. Most existing audiovisual hallucination studies focus on environmental sound as event indicator. For example, if the model hears a cat meowing, it may incorrectly assume that a cat is visible in the video. This is an important problem, but sound events are relatively simple. Human speech carries rich information and cannot be summarized as only a person is speaking. Our key finding is that speech content itself can induce hallucination. For example, if the speech says, "Put the egg on the cheese," the model may answer that the egg is visible, even when the visual evidence does not support it. This reveals a new failure mode. The model hears semantically meaningful speech, but fails to verify whether the spoken content is actually grounded in the video. To study this problem, we propose SVHalluc, a benchmark for evaluating whether audiovisual LLMs can ground speech in visual evidence. The benchmark contains two major task groups. The first group evaluates semantic grounding, what speech content is visually supported. The second group evaluates temporal grounding, when does the narrated action visually occur. Across these two groups, we design 6 diagnostic tasks. Here is example for semantic tasks. Here is example for temporal tasks. SVHalluc contains 2,405 video question pairs across 6 evaluation tasks. All samples are human verified for quality. This gives us a balanced and reliable testbed for studying speech-induced hallucination in audiovisual models. We evaluate both open-source and commercial audiovisual LLMs on SVHalluc. The results show that current models still perform poorly on speech-vision grounding. Open-source models are near random on multiple tasks. Commercial models perform better, but they still hallucinate. This indicates that speech-vision hallucination is a broad challenge for current audiovisual large language models. A closer look shows that global alignment can be even harder than fine-grained grounding. For example, identifying whether a specific object is visible may be easier than deciding whether the overall speech content matches the visual events in the video. We further analyze where the bottleneck comes from. Interestingly, the models performs well in perceiving speech. Speech recognition is strong, with a low word error rate, and speech time localization is also accurate. However, when we add text transcripts, the improvement is limited and does not solve the alignment problem. This suggests that the main bottleneck is not speech perception itself, but cross-modal integration. Models can hear the speech, but struggle to ground it reliably in visual evidence. To conclude, speech-vision hallucination remains underexplored in audiovisual large language models. Existing studies mainly focus on environmental sounds as event indicators, while speech provides much richer semantic and temporal information. SVHalluc systematically evaluates this problem with 6 diagnostic tasks and human-verified video question pairs. Our results show that current models still struggle to ground speech in vision, and strong speech perception does not guarantee reliable cross-modal understanding. This is the end of my presentation. Thank you for watching.